Hi kids, so today's lesson is going to involve another technique for evaluating limits algebraically. But before I do that, I want to just go over and give you the answer key for your assignment on yesterday. So just make sure you check your answers, see if you got to the same place that I did, and then we'll move on. Feel free to pause the video or I'll write fast, I don't know. All right, by the way, I didn't show any work, but I do expect you to have work shown. Okay, so the first thing we're going to do today is we're going to explore types of discontinuity. Now we did that in, I believe, lesson 1, where we talked about how to identify what type of discontinuity you get. So if you get 0 over 0, there's something we can either factor out or multiply by the conjugate, or and simply said, we could probably use just some simple algebra. If you get a number over 0, though, that is going to be an infinite discontinuity of some sort. So we'll have like no options. So the process for finding these discontinuities in rational functions, which we particularly where we see them, you're going to factor the numerator and denominator. And after you do that, you're going to simplify, cancel out that term that's making the top and the bottom 0. There are two results from that. Once you factor, a point discontinuity or a whole comes from factors that are canceled. A infinite, oops, that was crazy. This is like being in real life in class. An infinite or an asymptote comes from non-removable, or something when you have a factor you can't get rid of it. Okay, and so the technique we're going to talk about today is the factoring method or the cancellation technique. So here we see the limit as x approaches 2, and we can approach this rational function the same way given that we have the limit as x equals 2. So the first thing you should always try is to plug in. And when I plug in, I get 0 on the top and 0 on the bottom, which means that there is something we can manipulate algebraically to get rid of whatever is causing the 0 on the top or the 0 on the bottom. There's a huge clue because we got x approaching 2, which means that probably what happened is that is a factor that's causing a 0. So the first thing we're going to do is factor the top and factor the bottom. So we got the limit as x approaches 2 of x plus 3 times x minus 2. And our factoring techniques need to be like our best skill right now because there is so much algebra in calculus. Okay, and so it works out that we have x minus 2 on the top and x minus 2 on the bottom. And so when that goes away, we plug in again. And on the top, we're going to get 5 over negative 2. And just like when we talked about rational functions, this is the y value for the whole, but it also happens to be where the function is going. Okay, so this limit does exist. It exists at negative 5 halves or negative 2.5, depending on how you feel like writing it. But then what about it as x approaches 4? And so when we look up here at our factored version, we can see we have an infinite discontinuity there. So then we're going to look and see how is the behavior to the left or the right. And to the right of that function, so if we approach 4 to the right, we're going to the sky. So we got infinity, therefore dne. To the left of the function, or going this way, we see negative infinity, therefore dne. Okay. Consider what happens when you try to evaluate a limit using direct substitution. So sometimes direct substitution is going to lead us to 0 over 0, or a number over 0, or just a number, right? And so this is best case scenario. This one we still have some options, and this one we're kind of finished. When you get an indeterminate form, and that's what 0 over 0 is called, an indeterminate form, or infinity over infinity, your goal is to algebraically manipulate the expression in an effort to remove the points of discontinuity. Then you're going to try direct substitution again. So when we already kind of talked about this example. If you're approaching from the left, you want to put in a number slightly bigger than 4. So if I were to put in 4.1 plus 3 over 4.1 minus 4, what I'm going to see on the top is a positive number. I don't even have to evaluate it, although it's 7.1. And what I see on the bottom is also a positive number. Now I know that if I were to plug 4 in, I would get a number over 0, right? Because we know that we have an infinite discontinuity of 4. But this tells us that we have positive infinity, right? So this is going to positive infinity, therefore DNE. And on the left, we're going to pick a number slightly smaller. So we've got 3.9 plus 3, and we've got 3.9 plus 4. And now what we see is is a positive number over, this should be a minus, over a negative number, giving us negative infinity. Okay, and so that's how you evaluate those. And then that takes us to piecewise functions. So for piecewise functions, very similar to how we did the last example, you need to look at the left and the right. The left of this equation is going to be the bottom expression, and the right of this equation is going to be the top. The good news is we know that this is continuous, this first piece, and the line is also continuous. So we got continuous functions here. We'll get an answer now. Will they be equal? I'm not positive. So the limit as x approaches 1 from the right, we're going to plug 1 in, and g of x here is going to equal 2. And we're going to try it from the other side. We're still going to plug 1 in here because we wanted to see where it was going as it approached from the left. And so from the left, I get 2 as well. And so therefore, the limit as x approaches 1 of this piecewise function is 2. I'm going to leave B for you to practice and try. I don't want to steal all the examples. Very similar setup. We know we have a parabola facing up and a parabola facing down, so we don't have to worry about any point discontinuity. But work through it and let me know how it goes. And then that brings us to your assignment for today. We've already completed this one, so I'm going to write this -5/2 so you don't do that again. I'd like you to try B and C today for your assignment. Okay, if you have any questions, please let me know. Please make sure that you complete the Khan Academy video and the exercise attached to this assignment.